Okay, so for problem number 3, in a fluid, the velocity measured at a distance, okay, yung distance natin, dy, is equivalent to 0.075 meters, okay, from the boundary. So, yung velocity daw, du, is equivalent to 1.125 meters per second. Okay? The fluid has an absolute viscosity mu of 0.048 Pascal second. Okay? And the specific gravity of the fluid is equivalent to 0.913. So meaning, ang density niya, multiply lang natin yung specific gravity ng 1,000 is 913 kilograms per meter cube. So we have to find the velocity gradient. Alin yung velocity gradient? Velocity gradient is du over dy. So alin ba yung du over dy? So 1.125 meters per second over dy of 0.075 meters. So this is equivalent to 15 per second or second inverse. Okay? So, that's our first answer. The shear stress at the boundary. Alin ba yung shear stress natin? The shear stress is tau, which is mu du over dy. Okay? So, this is equivalent to 15 per second or second inverse. 15 per second or second inverse times 0.048 Pascal second. Okay? Etong 0.048 Pascal second is the mu du over dy yung na-compute natin. So, cancel lang natin yung per second. So, we will end up with our answer of 0.72 pascals. Okay? And the dynamic viscosity V, okay, is equal to mu over the density. Okay, alin ba yung mu? Mu is 0.048 Pascal. Ano yung Pascal? Newton per meter squared second over the density na 913 kilograms per meter cube. Okay? So, yung Newton is kilogram meter per second squared. Okay? And our dynamic viscosity, V, okay? If we will cancel out yung mga units natin, we will end up with an answer of 5.25 times 10 to the negative 5 meter squared per second. Okay? So, yung Newton natin, di ba, is kilogram meter per second squared. Multiply natin ng second over meter squared over kilogram per meter cube. Okay? Makakancel dito yung isang second. Okay? Yung kilogram. Okay? Isang meter. Okay? Tapos, may matitira tayong 2 meters sa denominator ng denominator. Okay? Tapos, itataas natin. So, meter squared per second. So, this is the dynamic viscosity. This is the shear force and this is the velocity gradient. Okay. So, problem number 4. So, we have a 4.9 cubic feet of water. So, 4.9 cubic feet of water. So, that's the volume. Okay? Volume is 4.9 cubic feet or feet cube of water is compressed to 5,000 PSIG. Ibig sabihin, yung delta P natin is 5,000 PSIG. Or gauge pressure, PSI. Bakit delta P? Kasi kinompress natin. So, mag-initial siya, usually 0, and the final pressure is 5,000. Kasi nga, Kinompress natin siya into 5,000. Ibig sabihin, mayroon tayong change of pressure na 5,000 PSIG. What is the volume decrease? Okay? Ano yung volume decrease? That is the change in volume. Okay? If the temperature is 60 degrees Fahrenheit, kung mapapansin nyo with our bulk modulus of elasticity, wala naman tayo dun or walang involvement yung temperature. Okay? Assume the average bulk modulus of elasticity E to be equal to 311,000 PSI. Okay? So, hinahanap natin yung delta V. Ano ba yung formula natin ng bulk modulus of elasticity? This is E equivalent to delta P over negative delta V over V. Okay? So, we have 311,000 pounds per inch squared or PSI equivalent to 5,000 pound per inch squared or PSI ulit over negative delta V over the original volume of 4.9 feet cube. Since this is feet cube times 1 foot, okay, 12 inches cube. Okay, solving for delta V, okay, change in volume. So our change in volume is 136.129 inch cube. Okay? So, delta V na yan. So, ibig sabihin, negative delta V. Ito namang negative dito, ibig sabihin lang, the final volume is less than the initial volume. So, absolute value of delta V is 136.129 inch cube or 0.13 inch cube kung ating i-convert into feet cube. So, 12 inches to 1 foot. Tapos naka-cube. So, delta V is equivalent to 0.079 feet cube. So, this should be the final answer.